Well, geometry students, we're finished with chapter 10 on circles, so we're ready for our gold sheet. Obviously, I can't get you a gold sheet right now, but hopefully you can go through with me and do a quick review of the whole chapter. In 10.1, we talked about parts of a circle and specifically tangent lines, but let's first look at the parts of a circle. On a circle, we start in here with the center, and the center is a point, so if you're naming it, make sure you write the word point and then whatever letter goes with it. From the center of a circle to the outside of a circle, you have what is called the radius. And remember, this is a fixed line segment. You don't want to have arrows on it. So if you write the name, make sure you just write a line above it, no arrows. Going from endpoints on each side of the circle and going through the center is called your diameter. And the diameter is always twice the length of the radius. Once again, that has a set length, so make sure you use a segment mark above it and no arrows on it. If you have a line that has endpoints on the circle, this is called a chord. And again, it's set one certain length. Make sure you use a line segment above it, no arrows. If you have a line ray segment that touches the circle once, this is a tangent. And as I just said, it can be any one of those, line, a line segment, or a ray. So when you name it, you can use arrows on it, or you don't have to. Either one is appropriate. You still name it with 2 letters, though. And then the one that goes through the circle twice and keeps going, this is the secant. And it's best to always use your arrows on the name of a secant above that. All right, those were the different parts of a circle. Specifically on the tangent, if a line is tangent to a circle, it is perpendicular to the radius. So if you have a circle and you have a tangent line, if you have a radius that goes up there, you're going to have a 90-degree angle right there every time. And the second thing about tangents are tangent segments from a common external point are going to be congruent. And I know you have a question or two on your review guide that includes this rule. So if you have a circle and an external point, if you have 2 tangent lines that go to the circle from that, these will be the same length every time. And that was 10.1. Moving on to 10.2. In 10.2, we started some of our arc measures. Most specifically, we talked about the central angle. The measure of a central angle equals its arc measure. So if the central angle in here is 75 degrees, the arc measure is 75 degrees. They are equal if your vertex is at the center of the circle. A minor arc is less than 180, so this 75 degrees would be called a minor arc. And usually it's named with just 2 letters, whatever they are. If we call this A and B, we would just name it A and B with a little arc mark over it. Major arcs are greater than 180. So I'm going to put a C over here. If I started with A and I went to C all the way to B, so I can call that actually arc ACB, and I can use 3 letters. That would be a major arc because it's more than 180. And semicircles are exactly 180. If I come inside here, this from here to here, this would be a semicircle. Half a circle, semi, that's what it means. It equals 180. And the entire circle we know is 360 degrees. So make sure you remember this whole diameter thing. If you see a diameter and you can make half of it equal 180, that'll help you a lot in solving for different arcs or angles in a circle. That was 10.2. In 10.3, we talked about chords. In congruent or same circles, congruent chords are going to make congruent minor arcs, but it also goes the other way. Congruent minor arcs make congruent chords. So whichever one you're given first, you can say it makes the other one and vice versa. If one chord is perpendicular and bisects another chord, it is a diameter. So if you see in a circle that you have 2 chords and it's perpendicular and it cuts it in half, then you know it has to be the diameter. And you can flip that the same way. If it's the diameter, it will be perpendicular and it will cut and bisect the other chord as well. Incongruent or same circles, chords equal distance from the center will make congruent chords, or congruent chords will always be equal distance from the center. And that picture usually looks like this. Here's the center, here's a chord, and you'll see this perpendicular line, because remember that's the shortest distance. So if you're equal distance from the center, you're going to be equal distant, or the chords will be equal. And if the chords are equal, you'll be equal distant from the center. Again, these reasons can go back and forth, so make sure you say whichever one comes first, then it makes the other thing true. All right, let's flip it over. That was what our first quiz was about. The rest of this is all the second part of the circle. All right, we have here, and oops, let me move it to the top because we want to do the angles first. So in our angles from 10-4 and 10-5, we had angles that the vertex is on the circle is going to be half the arc. Okay, we have a couple of them down here. Angles are on. If my vertex here is on, this will be half the arc. So if this angle is 15, it's half of this arc. Half of what number is 15? That would make this 30 degrees. Or if I have a chord and a tangent line here, notice the vertex is on the circle. So this vertex, this angle is going to be half of this arc. So half of 110 is 55 degrees. Angles that are in the circle are going to equal 1/2 of arc plus arc. And remember, it's kind of like those parallel ones. So if I want this in angle right here, it's going to be half of these. So in equals 1/2 arc plus arc. So my x here is going to equal 1/2 of 35 plus 95. 35 and 95 make 130. And half of that is 65 degrees. So I get 65 degrees here. Now, if you happen to want this other angle that you don't even know them with, just do a 180 minus 65 and get your 115 for that missing angle. So make sure you use the numbers given. Don't assign new numbers to those other arcs because you don't know those, okay? But in equals half that. All right. And then we have angles outside the circle equal 1/2 of big arc minus small arc. So if I have an angle out here, I follow my lines. I'm going to just put an X out here. It's going to be big arc minus small arc. It only uses the ones that are between the lines that form that angle. So out is going to equal 1/2. I often shortcut it to big minus small, especially on my space here. Okay, I have one issue. I don't know this small one, but I do know a circle is 360 degrees. So if I add 115 and 219 together, I get 334. I subtract that from 360, and I get 26. So this little arc in here is 26. Now for my outside angle, I can do 1/2. The big angle or big arc that's between my two segments is 219. Subtract my small arc, which is 26. I don't have to use that 115 in this calculation. I did need it for my arc though. So 219 minus 26 is 193. And half of that is 96.5. There's a slight chance my picture's not to scale, maybe. So, but that's your outside angles. Quick one too, just to remind you. If I happen to throw a diameter and I throw this little thing in here, okay? There is a rule that if you have a diameter that's part of an inscribed triangle, that makes this 90 degrees or right angle right away, okay? So a diameter forms that right triangle. You would also know that this intercepted arc is 180, so half of that is 90, so it fits this rule as well. And then the last one here, if a quadrilateral is inscribed in a circle, if its opposite angles are supplementary. Okay, that's a Y. So if I happen to have my quadrilateral inscribed here, these angles opposite each other will add up to 180, okay? They don't equal each other, they add up to 180. That's my supplementary rule. So those are all my angle rules mixed with that central one from the front side, okay? And now let's go over the segment points. Oops, sorry about that. All right, in 10.6, if we have two chords, notice here when I have two chords, they're inside the circle. This one gets a part times part equals part times part. And remember, one side gets all of one chord and the other side gets all the other chord. Okay, so on this one, I have, if I use this chord that goes this way first, I'm going to do 10 times 6. That's part times part. And then I get part times part of my other chord. So my other chord is 12 times x. 10 times 6 is 60. 12 times x is 12x. Divide by 12, and x equals 5. Okay. Sometimes it's not that easy. If there's binomials, you might need to do a little foiling, okay? But sometimes the math is that easy. All right, then we have two secants. This is the second example, okay? And on this one, we do out times whole on one secant equals out times whole on the other secant. Okay, now watch carefully when we get these, especially the whole. So on this top one, my outside segment is 4. The whole thing, out and in combined, is 9. On my bottom one, my outside part is x minus 2. My whole thing, I need to add these two segments together. So that gives me 2 x's, and a negative 2 plus 4 is a plus 2. So I get a 2x plus 2 for my whole. Make sure you're adding the whole thing together and don't just do the inside. It doesn't say oi oi, it says ow ow. Out times whole equals out times whole. All right, let's do some algebra here, and I hope I can make room here. I get 36 equals, over here I'm going to FOIL. Don't forget to FOIL. First times first is 2x squared. Outsides, x times 2, that's a positive 2x. Insides, negative 2 times 2x is negative 4x. And then last, negative 2 times positive 2 is negative 4. All right, it looks like I have a quadratic. I love to make this equal 0. So I'm going to subtract that 36. 2x squared stands by itself. A positive 2x and a minus 4x makes a negative 2x. When I subtract my 36 with my negative 4, I get negative 40. All right, here's a trick in case you didn't know this. Right now I have this 2 in front of my x squared, but it looks like all my numbers here are even. I'm allowed to divide by 2 as long as I do it to everything in that equation. I divide this by 2, this by 2, this by 2, and this by 2. And I get 0 equals x squared minus x minus 20. And you can use the quadratic formula. I prefer factoring. Are there factors of 20 that subtract to make negative 1 right there in the middle? There are. Factors of 20 are 5 and 4, and they can subtract to make 1. I need it to be negative 1, so I'm going to make my bigger number negative, my smaller number positive. So there's my factors that make, if I FOIL this out, I would get x squared minus 1x minus 20. And remember, if two things multiply to equal 0, that means either x minus 5 equals 0 or x plus 4 equals 0. Well, over here, if I add 5, x will equal 5. And here, if I subtract 4, x will equal negative 4. When I peek back at my picture, if x equals negative 4, I would get some negative segments. So I don't like that answer. I'm going to stick with just 5. When I plug 5 back in, I get a segment of 3 and a segment of 9, and that works a lot better. All right, last one, tangent and a secant. So here's my tangent on the outside that touches once. Here's my secant that goes through and hits twice. The setup for this one is tangent. This is super tiny, so don't feel bad if you make it bigger. Tangent squared equals out times whole. All right, so I have tangent squared equals out times whole. My tangent segment here is x. I'm going to square it. My outs part is 4, and be careful again, the whole thing here. When I add 4 plus 21, I get 25. I do my math. 4 times 25 is 100. Take the square root, and I do get 10. Do I always get a whole number? No, but this one came out nice. And that's your segments in a circle. Check 10.6 notes for more examples of that if you need to. All right, and we did one more section, 10.7, which was kind of completely different. Equations of a circle. We always start with this equation, x minus h squared plus y minus k squared equals r squared. The center is always opposite your h and k. So h and k, and it's opposite the signs. Let me write that little note for us so we don't forget this. Oops, I don't want the eraser. Opposite the sign you see. Okay? And the same thing, if you're going to plug it into your equation, you put opposite the sign that it is. The radius is just r, and you take that r squared at the end, and you take the square root of it, and that becomes your r. Remember, if it comes out to a whole number, leave it a whole number. If it doesn't come out to a whole number, try to leave it as a simplified radical. And there's a quick run-through of Chapter 10. Keep this handy, use it on your review pack. Don't be afraid to go back to all your homework assignments, because everything in the test and in the review pack, we probably did one similar in our homework. So go back and check them, or send me an email if you have any questions.